Right.
Yes, sir.
So, hello viewers, welcome to my channel. In the present class, so let us discuss the topic first TDS equation, second TDS equation, and third TDS equation. Right, sir. For any thermodynamic system, the entropy of the system is the function of temperature and volume. Entropy of the system depends on temperature and volume. So we can write it as S is equal to function of T into function of TV. S is equal to F of T. But the entropy ds is the change in entropy ds is perfect differentials. Therefore, for the perfect differential, we can write ds is equal to, because it is dependent of two variables. One is temperature, the second one the volume. ds can be written as dou s by dou t into t dt plus dou s by dou v dv. Dou s by dou t, here volume is constant. Dou s by dou v, here temperature is constant. So dou s by dou t plus dou s by dou v dv. Okay. If s is equal to f of xy, if ds is perfect differential, we write ds is equal dou s by dou x dx plus dou s by dou y dy. So accordingly, here s is the function of t comma v. Hence ds is equal dou s by dou t dt plus dou s by dou v dv. Okay, when you differentiate with respect to t, here volume is constant. When you differentiate with respect to volume, temperature is constant. That's why they are written over the bracket. Okay, sir. Now, uh, from this equation, just you multiply both sides t. So that equation we are multiplying with the capital T, sir, capital T. So then what we get, TDS is equal to T dou S by dou T at constant volume dt plus a T dou S by dou V T dv, sir. But dq equal to TDS. According to the second law of thermodynamics, dq equal to TDS. So therefore, the above equation we can write TDS is equal T into ds. T into ds you can write to dou q by dou T at constant volume V dt plus T dou S by dou V constant temperature and dv, sir. So this step next to we got. But dou q by dou T constant volume, that is nothing but CV. CV stands for specific heat at constant volume. Specific heat at constant volume CV is defined as, it is mathematically expressed as dou q by dou T at constant volume. So specific heat is nothing but, in the case of gases, we define two types of specific heats. Specific heat at constant volume, specific heat at constant pressure. Specific heat at constant volume, we denote with the letter CV. Specific heat at constant pressure, CP, sir. At constant volume, the amount of heat required to rise the temperature of 1 gram of gas to 1 degree centigrade is called specific heat at constant volume. At constant temperature, the amount of heat required to rise the temperature of 1 gram of gas through 1 degree centigrade is called specific heat at constant pressure. That is denoted with the letter Cp, small cp, small cv. That's it. So Cv is nothing but dou q by dou T at constant heat. So why the two specific heats exist for gases? Because gas temperature can be raised, gas temperature can be increased in the two ways, by keeping the volume constant or by keeping the pressure constant. When you keep the volume constant, then we define CV. When the pressure is constant, we define CP, specific heat at constant pressure, sir. Okay. Anyhow, CP is mathematically expressed as CP equal to dou q by dou T constant volume. But according to the Maxwell third thermodynamic relation, dou S by dou V at constant T is equal dou P by dou T at constant V. So therefore, in the above equation, right, sir? In this equation, there we have dou S by dou V at constant T. So that is replaced by dou P by dou T at constant volume. Then, so the above equation becomes as TdS is equal to dou Q by dou TV, we are writing CV dt plus T dou S by dou V over T, we are writing from Maxwell third thermodynamic relation dou P by dou T V dV. So this equation TdS is equal CV dt plus T dou P by dou T at constant volume V dV. This is called the first TdS equation. The first temperature and change in entropy TdS equation. This equation is known as the first TdS equation. Okay, clear, sir? Now, the second TdS equation or entropy of the system is also function of temperature and pressure. In the previous derivation, S taken as the function of temperature and volume. Here we consider S is the function of temperature and pressure. Sir. S is equal to F of T into P. Since the ds is perfect differential, right? As per our previous discussion, we can write it as ds is equal to dou S by dou T dt plus dou S by dou P dp. Dou S by dou T at constant pressure. Here dou S by dou P at constant temperature. Right, sir? Dou S by dou T dt plus dou S by dou P dp. Again, you multiply with the temperature on both sides. Then you will get TdS is equal to T dou S by dou T over P dt plus T dou S by dou P over T dp. Right, sir? Again, T into dou S is equal from second law of thermodynamics, we can write dou Q. Therefore, the above equation will get the form. The above equation we can write, right, sir? TdS is equal to T into dou S, we are writing dou Q by dou T constant P dt plus T dou S by dou P over T dp. Right, sir? Again, dou Q by dou T at constant pressure. This is called specific heat at constant pressure. We denote with the letter Cp. This is one thing. From second, Maxwell's second law of thermodynamic relation, dou S by dou P constant T. Dou S by dou P constant T, we can write minus dou V by dou T constant P. Okay. So in the previous derivation, we use the Maxwell third thermodynamic relation. To derive the second TdS equation, here we are using the second Maxwell thermodynamic relation. So what is that? Dou S by dou P over T equal minus dou V by dou Tp. So that is one substituted. And dou Q by dou T at constant P, it is replaced by Cp. So finally, we are getting TdS is equal to, this is Cp dt, right? Minus T dou S by dou P into T. This is replaced by dou V dou T P, sir. So minus sign there. Cp dt minus T dou V by dou T at constant P dp. This is called second TdS equation. TdS is equal to Cp dt minus T dou V by dou T constant P dp. This is called second TdS equation. Clear, sir? Now, so what is the third TdS equation? So in the first TdS equation, we consider S is the function of T and V. In deriving the second TdS equation, we consider S is the function of T and P. For the third TdS equation, we are taking here S is the function of pressure and volume. S is equal to F of V, F of P and V. Again, since the ds is perfect differential, now we can write ds is equal dou S by dou P dp plus dou S by dou V dv, right? When you take the partial differentiation with respect to pressure, your volume is constant. When you take the partial differentiation with respect to volume, pressure is constant. Therefore, they have written over the bracket. Okay, under the bracket as a subscript. This is the equation 1. Again, we are multiplying with the temperature on both sides. Then the equation changes as TdS is equal T dou S by dou P V dP plus T dou S by dou V over P dP. Okay, that equal to T on right hand side. Dou S by dou P, by rearranging, by modifying that equation, we can write dou S by dou T into dou T by dou P. Again, by cancellation of dou T, we'll get the same previous dou S by dou T. Dou S by dou P, how we are writing? Dou S by dou T into dou T by dou P over V dP plus the second term, that T dou S by dou V, we are writing dou S by dou T into dou T by dou V over P dP. Okay, therefore TDS is equal T dou S by dou T V dou T by dou P V dP plus T dou S by dou T P dou T by dou V P dV. Okay, TDS is equal here T into dou S from second law of thermodynamics. This is dQ. dQ equal TDS. T into dou S we can write dou Q. Dou Q by dou T over V, right? Dou T by dou P over V dP plus the second term T into dou S, again we are writing dou Q by dou T over P, and remaining dou T by dou V over P dP. But what is dou Q by dou T over V? This is specific heat at constant volume. See, what is dou Q by dou T at constant P? This is specific heat at constant pressure. So this is denoted with the Cp. So therefore, the is equation we can write TDS is equal. So dou Q by dou Tv, we are writing Cv, dou T by dou Pv dP plus, so this is dou Q by dou T over P Cp, dou T by dou P over P dP. So this equation is called as the third TDS equation. TDS is equal to Cv dou T by dou Pv dP plus Cp dou T by dou Pv dV. So this is called the third TDS equations. Okay, so in this present class, we discussed first TDS equation, second TDS equation, and third